Climate Now, in collaboration with Copernicus.
Hello and welcome to Climate Now, our unique monthly update on what's really happening to our planet. Coming up in our report, we're in the Dutch city of Utrecht with scientists hunting for hidden sources of methane.
I definitely think there is something underneath here, yes. That's
So
true.
there's greenhouse gases coming out of the ground here, right now.
Right now.
But first, let's check the latest data from the Copernicus Climate Change Service. Here in Europe, we just had the warmest summer on record, with temperatures from June to August almost 1 degree Celsius above the 1991 to 2020 average, just ahead of the previous warmest summers in 2010 and 2018. Now let's have a look at some of the data that we have for the month of August. And if we have a look at this map, you can see the temperature anomalies across Europe and how the continent is divided in two. Along the south and east, there was a sustained heat wave, and the city of Syracuse in Italy hit what may be confirmed as a new all-time European high on the 11th of August of 48.8 degrees. Then from France across to Ukraine and up into Scandinavia, temperatures were almost 1 or 2 degrees lower than average last month. Now to our story, and the IPCC report last month called for a big effort to reduce methane emissions from industrial sources. And that's because methane is a powerful greenhouse gas. In fact, over a 20-year period, it's 84 times more potent than carbon dioxide. Now, there are different approaches to finding methane leaks. You can use Copernicus satellites and models of the atmosphere to find unexpected sources of methane from oil and gas plants. And the other approach is much more down to earth and involves literally hunting for methane street by street, as I found out in the Netherlands. Scientists Hossein Mazalahi and Hannah Notto are on a mission to hunt for hidden methane leaks in the city of Utrecht. Methane is actually colourless and odourless. However, their instruments can detect it easily.
So if you have 1 billion molecules in the air and one of them is methane, these instruments can detect that.
Today we're looking for methane signals from leaking underground gas pipes. They can go for months or even years undetected, but not this one.
Yeah. Suddenly here it jumped all the way to close to 1,000 ppm.
1,000 ppm, or parts per million, is 500 times higher than usual levels. So there's definitely a methane leak here somewhere.
So what we do is sample the air, take it back to the lab, and then we can do a more thorough analysis of the sample and discover what the source of the leak is.
We're not ready for the lab just yet, though. Hannah and Hussein continue their search.
Yeah.
It's the background.
On another suburban street, they stop to check out a faint signal. Greenhouse gases are leaking out of a pipeline underground here, but it's tricky to tell exactly where.
This spot, yes.
The next methane plume is spotted downwind from a wastewater plant, and the team will aim to quantify the source.
We want to attribute the extra methane we see while we are driving. Not all of them are from the sewer system, not all of them are from gas leaks.
The samples are taken to colleagues in the lab to measure the chemical fingerprints of the methane to determine exactly where it's from. Their goal is for their fast and highly sensitive methane sniffing technology to be widely deployed to find and fix previously invisible leaks. Given methane's warming effect on our climate, it could have a powerful impact.
A recent scientific study has shown that it's possible to reduce methane emissions by 50% by the year 2030. And if we do that, we can prevent warming of 1/4 degree by the middle of this century, and even 1/2 degree by 2100. And this will be really a significant fraction of the warming that we're expecting. You can find out more about that team's work and see all of the data presented in this programme on our website, euronews.com/climatenow. And I'll see you next time.
Climate Now, in collaboration with Copernicus.